Hello guys, we'll be looking at how we could use COMSOL to create a model where we'll see the effects of multiple intercalating materials in a lithium-ion battery. So at the end, we should produce these results, these plots, and see how the effect of these multiple intercalating materials will be. So I think we can get started now. So we start by going to our model wizard, where we choose our space, working with the 1D space. So we choose 1D. Then we select our physics. So we want to use lithium-ion batteries. So we click on electrochemistry and we look for battery interfaces where we select lithium-ion batteries. Then we move to our study. We'll be dealing with time dependent with initialization. So we add to click our study. Done. It brings us to our interface, as you can see. So we look at our parameters and we want to load our parameters. Go. Programs files, console files. Batteries. So we will be looking at choosing our parameters from here. So when you go to your programs files, applications, battery fuel cells, lithium-ion battery, to bring it to this section where you have to load your parameters over here. And you can see we have several parameters that we can work with. There are several parameters over here that has been inbuilt in the COMSOL setup, as you can see over here. So we will be looking at the battery, the parameters that we're working with is right over here. We're looking at battery multiple materials parameters, as you can see over here, and we load it. So it brings us here. And when you load it, you get all these parameters over here. So this is what we'll be working with right here for work today. We can go ahead to build our geometry. We add an interval, specify the interval, make it interval length, and we input what the length will be. We want to use LNEG, LSEP. We want to add L positive. Afterwards, we build the selected, and it's been built over here. So afterwards, we can go ahead and add our material. We add from library. We choose our electrolytes first. Then afterwards, we add our electrode that will be dealing with. After adding your negative, you have to add your positive electrode too. So add LMO electrode 2 as well. And we close this material section. So as you can see, we have 2 positives and 1 negative. We'll look at the NCA, look at the basic equilibrium, and we look at the interpolation. Let's see how it looks. As you can see, and we will also look for that of LMO, look at the basics, look at the interpolation, and we plot to see the difference. See, there's a huge difference between that. Go on to add our variables, which will load from our file. We load from our file right here, multiple materials variables. As shown here. So these are the variables that we will be working with in our work for today. So it's very easy to locate where your variables will be if you follow what I'm doing exactly. We go to lithium and want to add a porous electrode to our work, and we select the domain, which is the first domain. We go on to choose. We look at the, before that, let's open our material section, then to close the side. So at the porous electrode, we go down and we define the electrode material. So we look at the electrode material here, and we want it to be, we've chosen here, so we want it to be the negative electrode, because this domain already is indicated as a negative. And we look at the porous matrix. We want to define this, and you see it comes as detected as an unknown variable, as you can see over here. But later on, as we move on, it will be defined. Go to the particle intercalation. Very important, we select the material, which is a negative. We go to particle transport properties, where we look at the species concentration transport. We want to change this to the selection in here. Then we look at the particle mean center surface. We should use that of the negative. Look at particle discretization. We want to change the number of elements. We want to make it 20. In this section. You look at the distribution, and we want to make it linear at the particle discretization. And we quickly move to the porous electrode reaction. We look at the material, we choose negative. We look at the reference, exchange current density. Choose this. Specify this. Go to lithium. I want to add another porous electrode. We select the domain. We select the electrode material, which is the positive NCA. We change this electrode volume fraction as NCA. Change this to X. We go to effective transport parameter. Make this user defined. Correction factor should be this. Positive. And that of diffusion 2 has to be user defined. And the same same as this. So we did copy and paste over here. So we move to the particle intercalation. We choose our material. Select our material to be NCA. Move to our particle mean center surface, which we change to RP positive of CA. And we change the species fixed or to Baker. We did change it to Baker, so we change this to this. And we go to porous electrode. We change the material to NCA. We change the exchange current density. Oh. All should be in small caps. Then NCA in big caps. So small caps, right? Okay. We go on to add an additional porous electrode material. We select the domain. Then the volume fraction too has to be changed. this. Add the particle interpolation. And particle transport species as this. Concentration. We want to change this to solid phase concentration. Defined in here. We go to the porous electrode reaction one, then we want to define the material. We define the material. You have to select the material for this. So our material is positive. Also, you have to change this exchange current density to this. And we change the concentration to insertion concentration. Okay, so some input just the small caps has to be small caps I. So we go on to add a separator, which will select the domain. Separator is this section, and we replace the volume fraction set. Then electrolyte conductivity is user defined. As you can see. Also, copy this, same for the diffusion, has to be user defined. So we place this in here. So we go on to add initial charge distribution. the initial cell charge distribution. We want to make this section, the initial charge, battery cell setting as state of charge. We input this values as SOC underscore cell. Yeah. And this section is also underscore there. No, this is but we move to the negative electrode selection, and obviously we have to select this section for it, that because that's a negative domain, and also do that for the positive, select the section. So after doing this, we go on to check where our value wasn't, it's still unknown. It's because of, this should be underscore and it should be correctly named. So now that all our variables are, you go on to add an electric ground. Want to add an electric ground. We select a section. So it's this point that becomes our electric ground. Then we go on to add an electrode current. Add an electrode current to this as well, which we select where to be at the fourth. Go to defaults, and we want to click here and make our temperature T. We set it to T. We go on to mesh. We want, let's make it fine. Let's build. Okay. Let's go on to add an integration. Then we select boundary for this integration. We want it to be, so it's fourth. Let's name this integration as, we set the operator name to be a different name over here. How about we name it as end terminal? we set that section. How about we move to the current and we go to the time dependent and we change to 0 to 3, 6 we go ahead to show our default solver. And our time dependent solver, how about we change the times to store as this. And we go on to add a stop condition. We add our stop, our expression. So this will be our stop expression. So our output at stop, I want to deselect and check this. And we want to uncheck the default plots. And we go ahead to compute. Okay. So we've been able to compute this. It has given us some results. We want to add a 1D plot group. Where we want to name this plot group as constant. Discharge. We want to add a point graph to this. choose to end. We make a selection. If actually can actually paste this and it will actually be the same. I can use this paste selection to paste it. Right, and just click on it and go to go. We select the expression over here. Go to lithium-ion batteries. This is our expression that we should be using. Electric potential. When we plot it, gives us electric potential versus time graph of it. You can look at the plot settings. To check and change what should be at the y and x axis. On the y axis should be the voltage. The title, we want it to be this. We want to make some edit the axis. As you can see, so you go on to add another plot group. We're the 1D plot group. We want to name this as surface concentration of positive. And we'll add a point graph. We will select this and go on to choose particle intercalation. Then is the after solid phase we have insertion. And insertion particle concentration surface. Legends we want to show. We want to name this as NCN. We want to plot this. So we have our plots here. We want to duplicate this point graph. Want to change the expression over here. we want to select the insertion particle concentration. So we have insertion particle concentration. This is what we'll actually select for our work. So we just double click on it. It gives us this. Or you can just type this expression over here, and that will give you the same results. So we have our plots being done. We go on to the surface. Title, we want to name the title as want to name the y-axis as surface concentration. To do some editing of the y and x axis. Okay, so we plot this. We've seen some changes. We want to change the position of the legend over here to upper left. Let's see. So we go on to our steady solution. We want to duplicate our steady solution one. We want to name this as, we'll change this here to take the component from this first section. Material tool has been changed. Go to our results. We want to add a 1D plot group. We want to make this a particle concentration. negative. We change the data sets to this. We do our time selection as interpolated. We need to add a range. To start from 0, step 200, stop at 2000. We want to add this to this. We want to add another range to as well. We want to start at 2032. Step will be 2030. Then 2200. Let's add it. No, we make this 2030 instead. We add another range. And this would be so inserted or added our time range. We want to add a line graph to this. So we select one. Can also click here to select all, and we have to put our expression for this, which will be So we want to plot this, and here we have our plot. Let's check the x-axis. Name this as normalized particle dimension. We check this as well. We want this to be the particle concentration. And we want the title to be this. We add another steady. We go ahead to add a steady for this. Then we choose a time dependent with initialization. Steady 2, we want to change here to 0 to 600. We want to add the parametric sweep to this. We'll add the parameter for which we want to check it. So we choose this and we try to vary within these parameters. Go on to steady. We want to show the default solver. We go to solver 3. We want to see the time dependent solver where we want to make the output times steps taken by solver. How about after that we add a stop condition. We input the expression. Which will just be the same as, sorry, this expression. So you can copy and paste, but I'll type it again. Stop. 1 dots and that's the expression. Stop expression. We want to uncheck this. Add 1 inside. Okay. We want to also uncheck our default plots and begin to compute to get our results. We begin seeing some results. So we have our results. Now we go on to add a 1D plot group. We name this as voltage profiles. Voltage profiles. We'll make it parametric. We add a point graph to this. We take the data set from our parametric solutions. Highlight, select this point. And our expression will change to the electric potential. Our legends, we want to show manual '95 volume 5-1 mix of NCA and LMO. '5/7 mix. That's 55/45 mix. And we have 75/25 mix of NCA and LMO. We have 525/75. Then we go ahead to plot. As you can see, we have our plot of electric potential time showing different volume mix of electrode materials. When we go here, we want to change the y-axis to change our y-axis here. I want to name this as just the voltage and we want to title should be manual because voltage profiles for different mix fractions and for NCA and NCA and O. So after that, we want to manually edit the x-axis and y-axis. Bring this to 0. Bring this to 3 and bring here to 0.2. We plot. Okay, so now It makes it more better. Then we want to change our legend position to the lower left. You can see over here. So we've been able to see how mixing different positive electrode materials will have on the voltage on the battery during a period of time, and we've been able to plot these voltage profiles for different mixed fractions of NCA and LMO. Also made a surface concentration plots for the NCA and LMO electrode materials. Also, we're able to do some parametric study on how these different mixed fractions will have on the voltage over a period of time in the battery. So I'm glad we're able to produce these plots in this work that we did today. Okay, so thank you for your attention.